Hello world and welcome. I'm Rick, and today I'm going to be talking about keyboard mapping for the Vice family of Commodore 8-bit computer emulators. This is the 5th episode in my series to find an effective and efficient mapping from my MacBook keyboard to the various Vice emulators. Last time, we continued building our Vice keyboard map file and unexpectedly hit a wall. My plan to use the Mac's Option key to act as the 64's Commodore key was thwarted. The reason for this comes from the fact that combining the Option key with another key generates a unique key code. For example, Option Q generates a key code of OE. But not every key on the keyboard actually has a mappable Option key code. W is one of these keys. In this case, we get a code of U plus 2211. And it turns out that you cannot specify a mapping for this in the VKM file. The other three are J, K, and X. Just 4 keys, but that's enough to make the Option key a poor replacement for the Commodore key. Since I am determined to not use the Tab or a function key to map to the Commodore key, the best option I have is to swap mappings for the Control and Option keys. I think this will work because there really aren't that many cases where you need to combine Control with another key on the Commodore, so missing a few keys to map can be worked around. Some of those keys we already saw, the number keys that set color and enable or disable reverse mode. We already mapped most of these keys for the Commodore colors. Now we need to switch them to the Control colors, starting with Option 1, which was mapped to Commodore 1, and now needs to be mapped to Control 1, so the 2048 flag needs to go. And we can replace that with flag 4096, which means combine with the Control key. And that maps that, exclam down 704096, and on through the rest of the numbers. And that leaves mapping the Option key itself, which we assign the flag 16384, meaning this is the Control key. Unlike the Option key, the Mac's Control key does not affect the key code of any key pressed with it. And because there are some tricky mappings that I stubbornly refuse to abandon, that means I can't directly map to the Commodore key using the 8192 flag, because it will create a Commodore shift combination and change the character set on the 64. We can map the Control key, but without the flag. It turns out this doesn't really do anything, but it doesn't hurt anything either, and it makes the mapping clear, so I'll keep it. Let's look at our flags. Flag 1024 means the Control key is pressed on the host, that's the Mac. And we already know that flag 2048 means the key is combined with the Commodore key on the emulator. So that means a shift flag's value of 3072 should be what we need. Let's do that to map Control 1 on the Mac to Commodore 1 on Vice as 1703072. And it works. Well, almost. Although I can get orange, I can no longer type a 1. That's a problem. The problem is I've defined 2 mappings for the 1 key code, one to map the key itself, and one to map Control 1. Clearly Vice is choosing the last mapping specified. So how do we fix that? If we look at our flags again, there's flag 32. Another definition for this keysim scan code follows. We tried to use this once before back in episode 3, but it didn't work there. But in this case, maybe it will. So if we add that flag to our first key definition, making it 17032, then Vice should remember it as well as the second definition. And it does! I want to note here that it seems like Vice prefers this another definition follows flag to be applied to the simplest mapping first. When I was developing this, I first applied the 32 flag to the Control key definition, putting it above the 1 key definition. For whatever reason, this didn't work. The 1 key was mapped, but I could not get the Commodore 1 sequence to change my text to orange. I want to pause a moment here and mention a table in the Vice documentation that describes the shift flag values in a much more useful form. I found this while banging my head against the wall on some of the prior problems we've worked through here, and it is a much better explanation and guide to using the flags. I mention this largely to point out that Vice does actually have some pretty good documentation, though like much technical documentation, its value and clarity is usually best appreciated after a base level of competency is achieved. Back to the VKM, we can map the rest of the Commodore colors: brown, pink, dark gray, medium gray, light green, light blue, light gray. Since 9 and 0 have no Commodore sequence, there's no need for any additional mappings. That leaves the minus and equal keys. Mapped Commodore to the option key, we map the option minus key code N- to the 64's shift asterisk centered horizontal bar. We'll need to remove this mapping, and since we are going to add a control key mapping to the minus key, the original minus mapping needs that flag 32. And we can add our control minus mapping to shift asterisk. But what are the shift flags for that? Just like we combine flag 1024 to indicate the control key on the Mac is down with the flag for the Commodore key on the emulator, this time we combine that flag with flag 1 to indicate the shift key is down, for a value of 1025. And that maps minus. And control equal maps to shift plus. And we remove the mapping for not equal. And now, finally, we've mapped, or rather remapped, the second row. This time around, the third row of keys should be easy. We've already mapped tab, and its shifted version. For each letter, we need 3 mappings. I'll use Q as the example. The first mapping being the letter itself. The second mapping being the shifted mapping. And the third maps to the control letter pair on the Mac with the Commodore letter pair on Vice. So the first mapping will need the 32 flag, making it Q7632. Then we'll do the control letter mapping, which just like the numbers is going to use the 3072 shift flags value, so Q763072. And finally, the shifted Q mapping using the capital Q key code and the 1 flag. And we can repeat this for the remaining letters on the row. W, E, R, T, Y, U, I, O, and P. The bracket keys are a little different. The basic mapping of the left bracket is to the Commodore's shift-colon pair. That would mean we need the shift key via flag 1, but we also need another definition follows flag 32, making our final value 33. And that other definition is to map control left bracket to the Commodore minus pair as bracket left 5-3 and once again a shift flags of 3072. Then we can map the shifted left bracket or brace left to Commodore pound. If you remember from a prior episode, we need the 2048 flag to combine the key with Commodore and the 16 flag to de-shift the key so it doesn't do an inadvertent character set change. That means brace left 602064. That leaves the last couple keys. Right bracket maps to shift semicolon, and with control it maps to Commodore asterisk. Shift right bracket, or brace right, maps to shift pound. The last key is backslash, which is mapping to the Petsky character generated with shift M, followed by the control backslash mapping to get pi, which is shift up arrow. Finally, the vertical bar maps to the similar Petsky character from shift minus. The fourth row on the Mac has one real challenge: what to do with the caps lock key. The most likely mapping is to the Commodore's shift lock, which is similar, although it applies to every key on the keyboard, not just the letters. The keyboard debugger says the key code is caps_lock. But what key do I map it to? This is where that block of definitions near the top of the VKM file comes into play. These are also documented in the comments, which has a note about shift lock, or specifically the shift L specification, is going to map to either the right or left shift key in the keyboard matrix. There's an additional note about mappings for keyboards with a single shift key, but that doesn't apply, so best not to think too hard about that. The VKM says to map the shift lock key to the left shift key. So we map the caps lock to the left shift key at row 1, column 7. But what shift flags do we give it? Looks like 64 is what's needed, and with that, caps lock is mapped. The letters in the fourth row, which is known as the home row if you've ever taken a typing course, follow the same pattern as before. 3 mappings per key, so we can just race through them. A, S, D, F, G, H, J, K, and L. Mapping the semicolon key includes a control semicolon mapping to shift at, and mapping shift semicolon, which is colon, to its dedicated key on the 64. The apostrophe quote key ends up mapping to 2 different shifted number keys. Apostrophe maps to shift 7, and double quote maps to shift 2. That leaves mapping return to return, and since shift return on the Commodore acts as a carriage return without executing the current line, we need to be able to handle both normal return and shift return, which means a shift flag's value of 8 will make sure both cases are mapped. With that, the VKM is coming along well now. Next time, we'll finish up with the last 2 rows of keys. Thanks as always for watching. I hope you'll join me next time as we complete the mapping file and reach the original goal, at least for the Commodore 64.